In this video, you're going to be exploring a secret technique in integrating. I'm not going to speak loud, just get a look at it. We have e to the x cos x. Let's figure it out. If you differentiate e to the x, you keep on having e to the x and e to the x as you move on. What about cos x? When you differentiate cos x, let's just take a look at the cycle. The cycle is what? Sine x cos x minus sine x and minus cos x. You differentiate, you have g's, you differentiate, you have g's, and so on. What do you see? Since you have at this point I equals to g's, if you differentiate at the point, you are going to have your minus integral of e to the x cos x. Yeah, x. And finally, you're going to bring it here to have 2I is equals to the answer. Yeah, that is it. Are you ready? Let's take it. Then we're going to use the GI method, differentiation and integration. What are you going to differentiate? Cos x. Cos x. And what are you going to integrate? E to the x. Okay. We put in the sign. You have a plus, you have a minus, you have a plus, you have a minus, and so on. You iterate it. Therefore, if you differentiate cos x, you are going to have what? Minus sine x. Okay. And if you differentiate minus sine x, you are going to have what? Minus cos x. What about e? If you integrate e to the x, you will keep on having e to the x and e to the x. Are you seeing what we talk about? We have that minus cos x at this point, hence we end here. We are not going to differentiate further, because differentiating further, you're going to come back again. Okay, continuing from here, you put it back and substitute. How are you going to take it? You take like this. This one is aligned with this one. This one is aligned with this one. And this one is aligned with the next one. That is e to the x. Okay, if you differentiate this also, I'm going to have the what? Negative cos x. So if you differentiate negative cos x, you're going to have sine x. Okay, this and this align. Okay, this and this will just end at this point. Okay, let go. Because it's vertically like this, like you see. We then substitute. The first thing is what? I take cos x e to the x. Therefore, I is equal to what? E to the x. Let's just write it here. I equals to e to the x cos x. Okay, that's our I equals to e to the x cos x times that plus e to the x. We have multiplication sine x. And then you have minus, we keep an integral e to the x cos x dx. The question I'm going to ask you is, why are we putting this integral? Because we didn't have a constant. Okay, that is why we keep the integral compared to the other method earlier. Because we had the constant, we don't have to put the answer. Therefore, this is why we end. If you bring this on this other side, you're going to have what? 2I is equal to e to the x cos x plus e to the x sine x. Yeah, therefore I, this is I is equal to e to the x